There are multiple ways to deploy a Spring Boot application to Google Cloud. The easiest one is using Google App Engine. That is the topic of the last video on this channel, card at the top. The problem is that if our deployment has several instances, the cost can add up very fast. A more cost-effective alternative is deploying it as a compute engine instance group and then exposing this instance group to the internet using a load balancer. And that is what we are going to explore in this video. We will write a basic Spring Boot project from scratch, then create a Docker image out of it. We will see how we can do this with both Maven and Gradle. Next, we are going to deploy this Docker image as a compute engine instance group in Google Cloud. And lastly, we will expose this instance group using Google load balancer. And the load balancer will use a Google managed SSL certificate. This is a very nice feature in Google Cloud. It means we don't have to purchase SSL certificates from third parties, and also we don't need to handle renewing them. As usual, the source code and the commands we use will be linked in the video description below. And if you want to support the channel, please like the video or consider subscribing. It makes a big difference and it helps the channel grow. Thank you. We are going to start by opening the Spring Initializer website. Just search for Spring Initializer on Google and there will be this website. For now, we'll use Gradle Groovy. We usually use Kotlin on this channel for Spring Boot. It's not very important for this video. You can use Java if you like. The artifact name will be boot-GCE. This is good, jar. And for dependencies, we need to add Spring Web because our project will be a web service. Then we also add DevTools. We always add it. It's easier to work if because of hot swapping enabled. It makes development much faster. And we will also add the Spring Boot Actuator. And we will use the health check endpoint from Actuator as a health checker in Google Cloud in the instance group. This looks good. Now we generate this archive. It will prompt us where to save it. That is a good location. And now we just extract this zip file that was just generated. And we can open it in the IntelliJ IDEA Community Edition. This is a free IDE that you can use. It lacks some of the features from the Ultimate Edition, but it's very useful. It's good enough. So in here, boot GCE. We open that directory. And it will take a few minutes to index. I will skip ahead. Next, we will add a basic controller to our project. So in source main Kotlin, we'll just add it in our main file at the bottom. So we'll have a class main controller. And this one will have the annotation at the REST controller. And in here, we will have function index that just returns a string, hello world. And the annotation will be get mapping with the path of //index. So now if we just run this project, we see that the server is running on port 8080. So in the browser, in localhost 8080, we will see the hello world message. Also, because we added this dependency to our project to Spring Boot Actuator, our server has a health checkpoint enabled by default under the path Actuator and health. And this endpoint will be used to indicate to Google Cloud that our server is running and can accept requests. There are other Actuator endpoints that you can use. So if we search for Spring Boot production ready endpoints, we will find a list with all the actuator endpoints. This is the one we used. Health shows the application health information. There are other ones, let's say info, display arbitrary application info. Some of these endpoints are read-only, they just display information. And other endpoints, with other endpoints, we can make changes to our server while it's running. For example, this one, loggers, we can modify the level of different loggers. And also there's this one that we can shut down the server if we make a request to that endpoint. Because of safety concerns, all of these endpoints except for health are disabled by default, and you need to enable them explicitly. There will be information on this page on how you can enable them. Next, we will create a Docker image out of our project. And there are multiple plugins that can create Docker images for Gradle and for Maven. You also don't need to use a plugin. You can do it manually. Just copy a jar inside the Docker image. But one plugin that I like is called the Jib. So if we search for Gradle Jib Docker, JIB, and we find this URL from GitHub. It says containerize your Gradle Java project. So in here, we need to add the plugin to our Gradle file to the plugins section. So we go to build.gradle and add it inside the plugins. And if we scroll more inside configuration, it tells us how to configure our image path. And here it's specific to Google Container Registry, which is exactly what we need. And also there's this warning, make sure you have the Docker credential GCR command line tool. So I already did this on my local machine, but if it's the first time that you push an image to Google Cloud to Container Registry, you need to follow these steps. So the easiest option is to use the gcloud credential helper. Let's see. So in here you need the Google Cloud command line interface. This command, gcloud in your terminal. First, you need to log in. We won't use service account. You just use this one, log in, and then the second step is you just run this command gcloud auth and then configure Docker, and you should be good to go. But in our case, we need to configure the image in here as a variable. So we don't have a project right now. We need to create one on Google Cloud. So we just go to console.cloud.google.com. And from the drop down in here, we are going to click on New Project. And yeah, the name doesn't matter. What is important is this ID from here that we will copy. So we'll just create the project. It will create in the background. And for the Docker image, we copy our project ID in the image name. So now we need to reload this Gradle changes. We also need to give a name to our image. Let's say hello world in here. And I'll move my camera because it's in the way. So yeah, we made changes to the Maven again, so we need to refresh it one more time. And inside this Gradle tab in IntelliJ, we can also use Gradle in the command line. So we will see tasks, and there's this section Jib that was added by the plugin, and the target that we need is Jib Docker build. So we'll just execute it. Okay, Gradle finished executing. So now if we look at the Docker images that we have on our machine, so inside the terminal we do Docker images, and then our image tag, and our image tag is this one over here. And we see we have an image, but the problem is that the creation timestamp is incorrect. It says 52 years ago. That is a frequent issue with this Jib plugin, so we need to fix the creation timestamp. If we search in here, we will see there is this property creation time that we can set to use current timestamp. So inside the container section, so Jib container, then creation time. So in here, we will do Jib.container.creation time equals, and use current timestamp. Like that. We need to reload the Gradle plugin inside IntelliJ and run Jib Docker build again. This time will be much quicker. And now if we run Docker images again, we will see that our image is created 11 seconds ago, which is much better. We can try to quickly run our image to make sure it works. So we will use Docker run, and we also need to expose the port 8080 from the container. Let's expose it to 9090 in our local host. So this one, and then the image name. Oh, it says the port is already in use. Okay, let's try another one. Let's say 9099, 9099. It looks like that one was available. And yeah, we can see that it started. So in here, if we go to localhost 9099, 9099, we see the hello world message. Next, we'll see how we can create a Docker image, but in a Maven project. So let's stop this container for now. Just Control C in the terminal. So if we go back to Spring Initializer, everything stays the same. We just choose Maven from here. Let's rename the artifact Boot GCE MVN, and we generate this archive again as a zip, save it, extract it just the same, and I will open it in IntelliJ Community Edition and let it index. I will skip ahead a few seconds and be right back. Okay, so the Maven project we just created finished indexing. We can see here the name boot-GCE MVN, and it has a pom.xml file. And next we are going to create a Docker image out of this project as well. So we will use the Jib Maven plugin, is the Maven version of the plugin we just used. Just search in Google Jib-Maven-plugin. And on the GitHub page, there will be a section Quick Start, just like we had for the Gradle version. And what we need to do is just add this plugin configuration to pom.xml inside the build section. So in build, plugins, add our plugin. Also, we need to configure our image name. So this will be the image name we used in the other project. We need to leave GCR.io. This is for Google Cloud. This is the project ID of the project we just generated, and this is a name we chose. And we're just going to add a suffix to distinguish between the Gradle and Maven images. And also we need to set the creation timestamp. So inside container, there will be creation time. And we will do use current timestamp like that. And next, again, if you skipped ahead in the gradle section, you need to follow these instructions to make sure you have Docker credentials, GCR command line tool. And once you have that, we can build our image using this mvn compile jib docker build command in the terminal. So we'll switch directories to boot GCE mvn, yeah. And just run this command in the terminal. Of course, we need to save the changes we made to pom.xml. And it's gonna take a while for the build to finish. The image finished building. So if we do docker images and our hello world mvn image, we will see that yeah, it was created recently. So everything is in order. Now we can switch back to our Gradle project and continue on pushing the image to Google Cloud Container Registry. So minimize this one and bring in the Gradle project, and also in here navigate to the Gradle project. First, we need to enable container registry in our Google Cloud project. So if we go back to the Google Cloud console.cloud.google.com, we need to switch to the project we just created from this project selector at the top. In my case, it's this one, Focus Healer, and the ID will be different for you. And in here, we search in the bar for container registry. And just click on enable. Okay, and once it's enabled, it took like 30 seconds to me. We can now push the image to the registry. But before we do that, we need to add an additional profile to our server, and that is because our application needs to run on port 80 inside the compute engine, and right now it's running on port 8080. So we will add a new profile in here. We'll create a new file, application dash prod for production dot properties. And in here, we will add one property, server.port equals 80. We save this file. So now we just need to rebuild the image. Actually, in here, it is selected jib docker build. Okay, very good. And now if we list the images again, docker images, and our image name. We will see the image that was created 23 seconds ago. So now all we need to do is docker push and our image. I skipped forward a couple of minutes because the image needs to upload to Google Cloud, but we now see that it finished. So if we go back to the Google Cloud console to container registry and we refresh this page, we will see that our image was uploaded, and the hash is the same one, 892.168, etc. Now we can deploy this container image to Compute Engine. But first we need to enable billing in our project. So in the bar, we can search for billing and just go to this page, billing, in here. And if you scroll down to account management, make sure you the project we just created. In my case is this one, Focus Healer, is listed to the billing account. Of course, you need to create a billing account, add your credit card, all that stuff. But once that is completed, now we can search for Compute Engine in the bar. And we can enable this API. First, we will deploy our Docker image as a single VM, not as part of the instance group. So in here, we'll just click on Create Instance. And we need to give it a name. Let's say hello single VM. We select the region that we are interested. I select US West 4 because it's always closer to me geographically. And in here we see the estimate for the type of machine we choose. We can select E2 micro is good enough for single services, which is the cheapest one. And if we scroll down, we will see in here the deploy container. So we need to provide an image name from GCR. So in here, actually, for now, let's open another tab with Google Cloud and just search in here for container registry, because we need to get the exact name of our image. So in here, in the Hello World image, we copy the full image name. So we go back to Compute Engine, and here we can paste the container image name. We see the first few digits, 89216. They are the same as here, just double checking. And we need to set an environment variable called Spring Profiles Active. And the name of this one will be prod. And if you remember in our project in here, we created this profile application.prod, which makes our server run on port 80. And this is important for a Compute Engine because the server needs to run on port 80. It's the easiest setup. And if we scroll down in here, we need to allow HTTP traffic like that. And now we click on Create. Okay, so our VM is running right now. We see the status, this green check mark, and it was assigned this external IP. This is an ephemeral IP, so if we stop the instance and we restart it, it will get a different IP, so you cannot add it right now to a DNS, but you can make this instance use a reserved IP. There is a small cost, I think $1-2 per month, and then that IP you can add to your DNS registry. So here, if we open this IP in a new tab, we see that our server is visible on the internet, and we see the hello world message we just configured. The problem with this method of deployment is that our connection is not secured because we are using HTTP and not HTTPS. Of course, you can purchase a certificate from a third-party website. I think there are some available for $10 a year. And then you need to convert that certificate to be usable in Spring Boot. And the server will run on port on the HTTPS port. And that will work. But you need to do a bit more work to have a single VM use HTTPS. But next, we are going to deploy our service as an instance group. So for that, we first need to go to Instance Templates and create a new instance template. Let's say hello template and then v1. Again, it asks us to select what types of machines we want. We will select the micro type because they are the most affordable. And here we select the image name that we want deployed for this template. And again, we need to add an environment variable Spring Profiles active prod. That looks good. And also allow HTTP traffic, and click on create. Once our template is ready, we can create an instance group out of it. But before we do that, we need to first create the health check. So in here, in the instance groups section on the left menu, there will be health checks. So we will create a new health check. Let's call it actuator. And yeah, the protocol would be HTTP. The path will be actuator health. And yeah, the criteria is good. So we just click on create. And we will go back to instance templates. And now in the right three dots in actions, there will be create instance group. So we need to give it a name to our instance group. Let's call hello-service. And we can select the template that we want. Let's say hello template v1. The zone that we want for our instance group. In my case, I will select US West 4, but select whatever is appropriate for you and your users. And now we can keep auto scaling on or off. So there are several ways to auto scale our service. Let's say the default one is CPU utilization. So we start with one instance, and if the CPU utilization is above 60%, then Google Cloud will deploy additional instances to balance the traffic out. In my case, I will select off for now. And in here, the minimum number of instances will be 1. And we cannot set a 1 as the maximum. It needs to be strictly more than the minimum number. So we will select 2, because when we deploy a new version of our service, a new template, it needs like some wiggle room to do the deployment. Like that. And auto healing. So whenever a server is determined it fails the health check, Google Cloud will redeploy it based on the rule we selected. And we have the health check we just created. It's called actuator in this drop down menu. Yeah, we don't need to map the ports. We just click on create. Our instance group was created. This warning sign in here is because auto scaling is off. But if we click inside the instance group, we will see that they are 100% healthy. And there's a list of all the VMs managed by this instance group. In our case, we only have one VM, which of course has an external IP. This IP is ephemeral, so don't use it in your DNS. We see the message in here. And there are a couple of operations that we can do on the instance group. We can restart or replace the VMs, or we can update them. And this will allow us to replace the template to a different one. We will want to do this, for example, if we want to change the hardware specifications of our VMs, or if we want to change the Docker image that is being used by the VMs. And this is what we will do next. We see how we can update the Docker image on all of our on our entire instance group. So if we go back to IntelliJ, and we can change this hello world message. Let's just say hello world XYZ. So if we run again this Jib Docker build target inside Gradle, this will create a new Docker image. Okay. And if we do a Docker push for our image in the console, this pushed a new image 3022 to our container registry. So if we go to container registry tab, we see it in here, 3022. So now we will go to Compute Engine to instance templates. So one thing to note about templates is that they are immutable. So if we want to change anything in one template, we need to create a copy of it. And that's why I versioned the first one with hello template v1. So in here, if we click on the template, there's this button called create similar. And in our case, this one will be hello template v2. And in here, yeah, we can change the machine types if we want. We won't change that. We'll just change the inside the container. We will use the new container image. So if we go to images, we copy the full image name for 3022. And we paste it in here. We just make sure 3022. This looks good. We select and we create the hello template v2. It will take a few seconds for it to be created. But in the meanwhile, we can go back to instance groups. So in here, we go to hello service again. And if we click on update VMs, in here, we can have two templates running on the same instance group. Let's say we have 10 VMs in total, and one VM can run the new version as a canary, and the other 9 will run the old version that we know is stable. And there are multiple options in here, but in our case, we are just going to replace v1 with v2. So hello template v2 in here. Yeah, that looks good. And we click on update VMs. Okay, so we see that it is deploying hello template v2. If it is not deploying it for you, you can just do replace restart VMs. But in our case, it is picking it up. It will take a little bit for the VM to come back up with the new template. Okay, so now it says ready, and in here in the template column it says hello template v2. And if we open the external IP of the VM, we will see that it has the updated message hello world XYZ. And lastly, for this video, we will expose our instance group to the internet by using a load balancer with SSL termination. So if we go to Compute Engine in here, we will search for load balancing. And in here, we will click on Create Load Balancer. Yeah, we want this one, HTTPS load balancing. Let's say from the internet to my VMs, that is good. Yeah, global, we want that one, not the regional. Okay, so the front end of our load balancer will be HTTPS, and it will be an IPv4 address, and here we need to reserve a static IP address. I think it costs like $1 or $2 a month. Let's say hello-IP, we need to give it a name, and it will be reserved. Okay, very well. And for a certificate, we will create a new certificate. And this is a very nice feature that Google Cloud Load Balancer has. It can create these Google managed certificates. And we just need to, you need to have a domain already purchased. In my case, I have a domain called turboflags.com, and the subdomain that we will deploy our instance will be YT from YouTube, so yt.turboflags.com. So let's name this certificate YT Turbo Flags, and we will click on create. Very nice. We need to give a name to our load balancer. Let's call it hello-lb. Okay, GCP default, that is good. Okay, so we only need one front end in here for HTTPS. Now we need to do a backend, and from the drop down, let's see, create a backend service. And in here, yeah, it will be an instance group. Let's see, hello BE service for a name we just generate. So in here, the instance group, we see the instance group we just created is called hello service. Port numbers, we use port 80 in the instance group. The utilization 80%, that is good for now. We click on done. Okay, let's see. Yeah, so the load balancer can enable CDN to accelerate to cache images and other static assets, make web requests faster. That is a very nice feature. For the health check, again, we have the actuator. Everything else looks good. We click on create. Okay. Create. And it will take a little bit to create. Okay, I skipped ahead about a minute for this load balancer to create. But now if we try it on a different tab, so the address will be https yt.turboflags.com in my case. In your case, it will be the domain and certificate you registered in. Wait, actually no. I lied. We need to add the IP to my DNS domain first. So I will go to Google Domains. In here you will go to your DNS register, not to Google Domains necessarily, but the steps will be similar. So if I open my domain in here and in DNS and in manage custom records, you need to add a new A record to your DNS registry. So create a new record. Let's see where. Okay, so this one will be YT. Type will be A. And for the IP, we need to go to the load balancer and copy the ID address that was the static IP address that was just reserved by Google Cloud. So in here, we store this one in here and we click save. So now if we go to HTTPS and the domain we just registered, it will take a little bit, like maybe a few minutes for the DNS changes to propagate through the entire internet, but keep on refreshing the page. Also, after a few minutes, you might get this error message that says the SSL version or cipher mismatch, and that is because the certificate in the load balancer takes a while to be created. So if we click in our load balancer in here, and in this certificate, we will see that it was created 9 minutes ago, but the status is still provisioning. So they say please wait 24 hours for a certificate provisioning before contacting support. In my experience, it doesn't take that long. It takes like 20, 30 minutes, 10 minutes. I'm not sure, but yeah, just wait a little bit and it will work eventually. Okay, now it should be good. So if we reload the page, we see our message, hello world XYZ, and the connection is secure. If we click on certificate, we see that it is valid. This is one of the coolest features in Google Cloud. I like it a lot, not having to generate certificates, manage them. So basically what happens is that we make an HTTPS request and it hits the load balancer. The load balancer returns an HTTPS response, but internally it will convert it to an unencrypted message inside Google Cloud to the instance group. So the VM will just process a normal HTTP request on port 80. Before we wrap up this video, I want to discuss the pricing of the Google Cloud Load Balancer. So let's search Google Load Balancer pricing. And this is something that you need to keep in mind. And the main, so yeah, the traffic ingress, egress is not very expensive. The one that is expensive is the, I think the rules, the forwarding rules. Let's see. No, not firewall rules, but yeah, yeah, it says the first 5 forwarding rules is 2.8 cents per hour. In our case, we only have one rule that sends all the traffic to our instance group, but we still fall into this category. So if we multiply 0.028 for 24 hours in a day, that's 67 cents per day. If we multiply by 30, that's about $20 per month, which is not the cheapest service. And then we also need to add the around $7-8 for the for each VM in our instance group. And then we have the static IP. Let's see. Static IP address, that is 0.011 times 24, that is 26 cents per day. So yeah, static IP is almost $8. And yeah, it adds up. Of course, if you don't need this project right now, I would recommend that you delete all the deployments, the instance groups, the static IP, you release them, you delete the load balancer, or just delete the entire project altogether. This is all the material we have for today. There are more videos on this channel related to Spring Boot and Google Cloud. They will show up on the screen. If you run into any issues following this tutorial, feel free to post in the comment section below. I will try to help you out. Thank you for watching.